squared minus 8 x plus 81.
All right. Read a different one out. I don't want to do that one for this one. Sorry.
X squared minus 21x plus 80.
Plus 80.
Yeah.
Okay, that works. All right. Today, instead of just factoring this trinomial, we're now going to set it equal to 0, and we're going to solve. Whenever I have the word solve in the directions, the answer is going to be x equals a number. In this case, we're going to have two numbers. Okay? We're solving. The directions might say find the zeros. Exactly the same. It might be, instead of equal to 0, it might be equal to y. That's the same thing. Just change the y and put a 0. Step number 1, write this down, is set it equal to 0. It's got to be equal to 0 before you can try to factor it, before you can do the quadratic form, because before you can do anything, it needs to be set equal to 0. What if the problem looked like this? Is that set equal to 0?
No.
How would you get it equal to 0? You just move the 80 over by adding it over. Okay, if it's negative 80 here, I would simply move it over by saying add 80 to both sides. It's got to be equal to 0 to start off. Okay? Then we factor just like normal. We try to factor, we look for GCF. There is no GCF. So I make my parentheses, I say x and x, I say minus and minus. I break down 80. What are my factors of 80? 80 and 1, 40 and 2, 20 and 4, 10 and 8, 16 and 5. Do we have a winner? Why is 16 and 5 the winner?
Negative.
Because it adds up. 16 plus 5 adds up to what? Our middle term, right? 21. So I can put the 16 here and the 5 here. This is still equal to 0. I haven't done anything with the 0. I've just simply factored. Here's an important point that you need to understand. If I have two things equal to 0, A times B is equal to 0, what has to be true about either A or B? One of them has to be 0. If I multiply two things and it equals 0, either A is 0 or B is 0. One of them has to be 0. So I don't know which one is 0, so I have to break them up and say they're both equal to 0. So I say x minus 16 is equal to 0 and x minus 5 is equal to 0. I break them up and set them equal to 0. Then I simply add 16 to both sides, x equals 16. I add 5 to both sides, x equals 5. X equals 16, x equals 5. I have solved the quadratic by factoring. We have other methods, but if it factors, factoring is the easiest way to solve a quadratic. All right? Here's a question. We did this on the test Friday. What form is this quadratic in when it's in this form?
X-intercept?
Intercept form, right? What are the intercepts to the quadratic? 16 and 5. If I were to graph it, where would the parabola cross the x-axis? That's right. 1, 2, 3, 4, 5, right there. 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, right there.
It'd be at 10 times.
Right? It'd be somewhere, and it looks something like that. The intercepts are at 5 and 16. Nothing's changed from last week. Okay? If I wanted to find a vertex, I could do negative b over 2a and find it. I think you said negative 10 and a half, or positive 10 and a half. I could plug that in and find y. It'd be down here somewhere. The parabola's going up because a is positive. All these things go together, what we were doing last week. I'm not asking you to graph, but I do want you to see the correlation. Okay? It was in standard form. We factored it in intercept form. We found the intercepts. Some of your directions might say find the 0, and you're going to have to be able to find the 0. It's exactly the same thing as the intercepts. Okay? We're solving the quadratic. All right. One more thing I have to talk about. Everybody got this? All right. everything we've done so far, factoring, has been trinomials. You will see problems that look like this. And it'll say solve the quadratic. Notice you only have two. We call that a binomial. Equal to 0. This does factor. We have a rule. The rule is the difference of perfect squares. If I have a perfect square minus a perfect square, the difference of perfect squares, if both of these are perfect squares, then I have a rule that says this factors into x plus and x minus what?
4.
X plus 4 and x minus 4. It factors into x plus 4 and x minus 4. I take the square root, it goes there and there. I take the square root, it goes there and there. One's a positive and one's negative. Every single time. The difference of perfect squares. Now finish it out. What does x equal? You would break it up, but 4 and negative 4. I mean, break it. You probably won't have to start breaking it up until we start doing some problems tomorrow. Right now, you should be able to tell me negative 4 and positive 4. Is that pretty easy? All right. How about this one? What would that factor into?
X plus and minus 7.
X plus 7 and x minus 7. All right. How about this one?
X plus and plus 6.
X minus.
Addition, not subtraction.
So this is prime. Doesn't factor. Why not?
Not the difference.
Because the rule is the difference of perfect squares. Write it in your notes so that you remember. If it's a plus, you got a perfect square plus a perfect square, it's prime. It does not factor. X squared plus 36 is prime. It does not factor. Okay? Special case. How about this one? X squared minus 24. Can I break that up?
No. Well, you can.
Is 24 a perfect square? No, it's not. So if they're not both perfect squares, then they don't break down. All right, I got one more for you. Perfect square?
Yes.
Perfect square? 1 times 1 is 1. So it's a perfect square. Is minus in the middle?
Yes.
All right, what would it break up into?
2x, 2x,
2x and 2x.
and a
Plus and minus
1.
1 and 1. Okay? Don't let these special cases trip you up. Okay? They're easy problems. Don't make them harder than they are. Okay? All right, let's practice some. Get your workbook out. Turn to page 76. Peterman, if you'll cut it off for me, I appreciate it.